Hello guys, hope you will be fine and taking good care of your health. Welcome to this video. In this video we are starting unit number 9 and today our first topic is transfer of heat. To understand the topic of transfer of heat, we recall our previous chapter. Recall what happens when two bodies at different temperatures are in thermal contact with each other. Thermal energy from a hot body flows to a cold body in the form of heat. This is called transfer of heat. There are three ways by which transfer of heat takes place. Number 1, conduction. Number 2, convection. Number 3, radiation. And these three topics we discuss in a whole chapter of unit number 9. First of all, we discuss what is conduction. We define it, the mode of transfer of heat by vibrating atoms and free electrons in solids from hot to cold parts of a body is called conduction of heat. You know that solids are made up of small atoms, and when we heat them, they starting vibrate. And when they starting vibrate, due to their vibration, heat transfer from hot body to cold body, and this mode of transfer is called conduction. And in conduction, the most important topic is thermal conductivity. First of all, in thermal conductivity we need to understand what is rate of flow of heat. So first of all, we define rate of flow of heat. The amount of heat that flows in unit time is called the rate of flow of heat. Now we define thermal conductivity. The rate of flow of heat across the opposite faces of a metal cube of a substance maintained at a temperature difference of 1 Kelvin is called the thermal conductivity of that substance. Thermal conductivity of a substance depends upon, or heat flows through a solid object depends upon following factors. First of all, cross-sectional area of the solids. Larger cross-sectional area A of a solid contains larger amount of a molecule and free electrons on each layer parallel to its cross-sectional area, and hence greater will be the rate of flow of heat through the solid. So rate of flow of heat rate of flow of heat, it's rate of flow of heat directly proportional heat, that is denoted by Q over T, is directly proportional to the area. We say this is equation number 1. And the second factor on which heat flows depends upon, that is length of the solid. Okay, now we discuss length of solid. Larger is the length between the hot and cold ends of the solid, more time it will take to conduct heat to the colder end, and smaller will be the rate of flow of heat. Thus, the rate of flow of heat rate of flow of heat that is denoted by Q by 2 is inversely proportional to the length. And third factor is temperature difference between ends. Greater is the temperature difference T1 minus T2 between hot and cold faces of the solid, greater will be the rate of flow of heat. So Q over T directly proportional to T1 minus T2. We say this is equation number 2 and this is equation number 3, and from here we can, if we combine these three equations, we get Q over T directly proportional to the A and T1 minus T2 and inversely proportional to the length. You know that when we remove proportion, sorry, this is Q over T. You know that when we remove proportionality constant, we place two things. Number one is equal symbol and number second is proportionality constant. A into T1 minus T2 over L. And you know that here K is the proportionality constant called thermal conductivity of the solid. Its value depends on the nature of the substance and is different from different materials. If you want to find the value of K, we can easily find the value of K, that is equal to Q over T multiplied by L over A into T1 minus T2. अब ये जो होगा ये यहाँ पर जाके क्या हो जाएगा, डिवाइड लेफ्ट साइड पर, और जो L है वो जाके राइट साइड पर जाकर क्या हो जाएगा, मल्टीप्लाई हो जाएगा. तो यहाँ पर देखिए डिवाइड हो रहा है, ये मल्टीप्लाई हो रहा है Q over T से. So from this formula we can find the value of K. And our next topic is convection. Definition of convection is transfer of heat by actual movement of molecule from hot place to a cold place is known as convection. And liquid and gases are poor conductors of heat. However, heat is transferred through fluids, means liquids or gases, easily by another method, that is called convection. Means जो conduction था उससे दूसरे method है वो convection है. And the most important topic of convection is convection currents in air. Gases are also expand on heating. ऐसा नहीं है कि solid expand होते हैं. Gases are also expand on heating. Thus, convection currents are easily set up due to the difference in the densities of air at various parts in the atmosphere. Use of convection currents is convection currents set up by electric gas or coal heaters help to warm our home and offices. Central heating system in building work on the same principle by convection. Convection currents occur on a large scale in nature. The day-to-day temperature changes in the atmosphere result from circulation of warm or cold air that travels across the region. So these are our today topics. There are only two topics are remaining of chapter number 9. Then we discuss problems and exercise of chapter number 9. So I hope you understand this carefully. If you have any problem, you can contact me on my WhatsApp number. Allah Hafiz.